the GPS localization, wireless networking, and motion planning to create a fence-less approach to herding animal. So you want to gather the animal, in fact, herding meaning gathering the animal together. All right. So let's look at this project in a little bit more details. Aerial view of the Cobb Hill Farm, that is the name of the farm. An area approximately 1 kilometer on a side. The component of the smart collar include Zaros PDA, that is a name of the software, and basically the Zaros PDA is a very old one. Of course, the project was in 2004, 2005. This PDA created by the Sharp company. All right, I think now it's not available anymore. The Wi-Fi compact flash card with the GPS protective case for the Zaros, and also the audio amplifier with the speaker also, as you can see in the picture, and a fully assembled smart collar with PDA case open, and of course the cow wearing the collar. All right. So let's look at the system hardware, and next we will look at the system software. The component of a collar, as I said, the computer is a Zaros PDA with a 206 megahertz Intel processor, 64 megabit of RAM with an additional 128 megabit SD memory card. It runs the embedded Linux operating system with the Qtopia window manager. All right, it has a serial port and a stereo sound port. A socket brand 802.11. You know that 802.11 is for the wireless, right? This is a protocol name for wireless. Later I will explain a little bit about this one also. And also a GPS connected to the serial port of the Zaros, and also a small guitar amplifier to reproduce the sound from the Zaros audio port. All right, that is a system hardware. For the system software, the fences can be added or removed at any time from the cow neck. Several fences can be combined to create the convex polygonal shapes. And also the GPS reading indicate, right? The sounds are stored in wave format. This is we're talking about the software itself, right? The volume can be from 0 to 100%. The sound basically volume can be controlled. All fences use the currently selected sound and volume, which can be changed without redefining the fences, right? With the GPS, we can have the, the area or the place of the cows, right? The location of the cows. It also sends a periodic live message indicating that the collar is function or not. That is also very important. Okay. So how the message handling is done is using the ad hoc protocol. All right. We already discussed about the ad hoc protocol. All right. And as I said, the protocol 802.11 is using for the Wi-Fi. Right. So all Wi-Fi messages are multi-hop. We discussed about it. There are two message channels. The message outgoing from a base station and incoming to the base station. The outgoing is used for defining the fences, and incoming they carries the live messages indicating a caller is active. We want to make sure that the caller is working properly. And also it can carry the acknowledgement messages. Whenever we need to send some kind of control or acknowledgement message, we can use that one as well. So two type of control programs were used. One is the GUI, another one is text. And you know about the text control program like command prompt in Windows. right, compared to the GUI. The text control program can be run as Zarus or Linux laptop. Okay. And the GUI control program include the functionality of the text program, add buttons for of course this kind of things is just a graphic based one, right? So here is a result from that motion, all right, have taken, and we can do the further processing on that. All right, that we discuss about environmental application. So the next kind of application that we can discuss are the health application, like telemonitoring of human physiological data, tracking and monitoring the patients, and also the drug administration. That can be an example of the health application. Of course, you can find much more application and new application, of course, uh, about this kind of network. So let's look at the body sensor network. When we discuss about the health application, especially the human body, all right, we can mention about the body sensor network, or BSN for short. All right. So the medical application, the vital patient data, we need a wireless sensor linked with the B-side monitor, can be connected to the monitor, and then we can have a different type of sensor on the body, collect the data, send it there, and do the further processing. All right. So some of the requirement in minimum setup interaction and so on, and so the traffic per patient is less than 10 kilobit per second, for example. Right. That is the data about BSN. So as you can see here, we have a different, we can have a different type of sensor like toxins. We can have a glucose sensor, we can have a blood pressure sensor, and also hearing, vision, and EEG, which is stand for electroencephalography, right? To detect the abnormalities in your brain waves. So that is used for the brain. For brain, we call it EEG. For the heart, we call it ECG. Later we will see. So we can have different type of sensor here and there, and then collect the data, send it to the router, all right, or forwarding devices, and then from the forwarding devices, the data through the network can reach to the physician or the nurse or doctors, and also we can save it on the database for further use. So what is the difference between BSN and WSN? BSN is for body sensor network. WSN is a wireless sensor network. Of course, the first one in terms of the scale or size, WSN is large as the environment. But BSN is just a size of the human body only. So the number of node in WSN is very large. But in BSN, it's just a few numbers because you just want to put in our human body, right? The node size itself, of course, for WSN is a small size, but in BSN must be much more smaller, so miniaturization required. So the data rate depends on the application itself, but commonly is very low. Sorry. But in BSN, the data rate could be very high. All right. The context awareness for WSN typically not essential since node placement is static. But in BSN is very important because you should know where to place the sensor. All right. That is very important. The power supply, of course, for WSN is minimal, but BSN should be much more less than what we use in the WSN because of the restriction. All right. Uh, all right. Some of the BSN node you can see here. Sensor node for the eyes, different type of node you can see in this slide. So in medical, what basically would happen? The sensor in our body, or human body, collect the body information. Using the wireless transmission, the data will be forwarded. After processing, data is transmitted for analysis. A diagnosis is established. If required, an action is triggered or action will be taken. And the network connected node informs about the action, and the actuator take action. So we have discussed about the actuator also, right? If you want to send some control message or you want to control, take some action, you can use the actuators. In WSN previously we mentioned that sometimes most of the times the actuator and sync are same. All right, sync will be used as a actuator also. All right. The next example of the health application of WSN is a cardiac monitoring system. The cardiac monitoring system is for our heart basically. So we can use for our brain, or it can be used for the heart. As I said here, we call it the ECG, stand for electrocardiography, ECG. All right. It monitor for up to 14 days. For example, the ECG continuously radios the patient and so on. They collect the data from the body, from the heart itself, and using the PDA or any smartphone to transmit or to route the data using the cellular network to the computer. And from the computer, it can be forwarded to the service center, all right, or we can store it in our database and can be used by the nurse and also the doctors. So that is another example of the. So here two type can be used, Medtronic and Biotronic. The Medtronic, the patient periodically or when alerted, places an antenna on his body or her body and then capture the data, and the data will be forwarded to the computer or database, or can be checked by the physician via the web and so on. For the Biotronic is a fixed installation. So it's already implanted the device, and whenever is needed, automatically will collect the data. But sometimes you need the human to put the antenna in his body itself. That is a Medtronic, and the Biotronic is a automated one, is a fixed one already. So again, the data will be forwarded using the cellular network to the computer, to the database, and can be used by the physician or the doctor or the nurses via the web. The next example is the wearable monitoring system. So there is a cloth, you can use it. So it has a microphone, the different type of devices, the sensors and so on and so forth, and controller as well. It's kind of the actuator, basically the controller. So this data will be collected and using a wireless technology will be forwarded to the system or computer for further use. So here in this example, we have a WPAN or wireless personal area network. The thing that we discussed just now about the ECG or also EEG and so on, these data can be collected using a different kind of technology like Zigbee or wireless Wi-Fi. You can send the data to the personal server. From the personal server, you can use a Bluetooth or WLAN to send the data through the internet to the database or physician or medical server or wherever you want to send. So how basically I need to discuss about different type of network, wireless network. Quickly I will explain it, and then maybe we can understand these terms of like what is PAN, what is LAN, personal area network, local area network, body area network. I will just explain later in different maybe slide. Okay. In the room topology here, we have the medical information. Basically, here we have a patient. We can have the sensor on his body. We call it a low rate WPAN, wireless personal area network sensors. This data will be collected from their body, the patient body, forwarded to can be shown on the patient monitor as well in the same room, and using of course the LAN, WLAN or wireless LAN technology. And the data can be forwarded to the base station. From the base station, the data can be forwarded to the hospital network. All right, and maybe a nurse or physician or a doctor can check and see this information. All right. Some of the current project for the BSN at the time that this slide prepared, maybe 10 years ago or 15 years ago. But of course, you can find a lot of new project as well. The only thing